Okay, so in this video we're going to talk about using the half angle formulas. Um, Again, we would use half angle when we know that the angle is not on the unit circle, but we can double that angle to get some sort of angle on the unit circle. So your half angle formulas are as follows. Sine of the half angle is going to be plus or minus the square root of 1 minus cosine u divided by 2. The plus or minus in the front is based off of which quadrant the half angle would be in, not the angle that you're using to help you solve this problem. For sine, for the most part, we'll always use plus. It's very hard and very rare for us to get a sine that's in the third or the fourth quadrant where sine would indeed be negative. Cosine is going to be plus or minus the square root of 1 plus cosine u divided by 2. Cosine, again, is a little bit easier to get that negative, so you got to be on the lookout for that because cosine's negative in the first and the second quadrant, and it's very easy to find a half angle in the second quadrant. So make sure you're on the lookout for that with cosine. And then tangent is going to be 1 minus cosine u divided by sine, or sine over 1 plus cosine u. The first one is a lot easier to use because you're going to have the conjugate show up less than that one because you're not going to have something plus some sort of square root in the bottom, where the second one there you would have to indeed use the conjugate most of the time. So I would strongly suggest using the first one more than using the second one. Okay, so here's our first example. We have sine of 105. Remember, 105 is the half angle. This is in the second quadrant. And sine is positive in the second quadrant. So we're going to use the positive version. And then we're going to take that 105. Remember, this is the half angle. We've got to double it. So when we double 105, we get 210. So we're really taking the sine of 210 divided by 2. Okay, so that means we're actually equaling the square root. It's a plus technically in front. 1 minus the cosine of 210 divided by 2. So cosine of 210, right? 210 is in the third quadrant, so I know it's going to be a negative. So I know that minus there is actually going to end up being a plus sign because a negative times a negative is a positive, so it's going to be 1 plus, and then cosine at 210 is going to be the square root of 3 over 2. Again, it was negative, so I made it positive because it was a negative times a negative divided by 2. I do not enjoy working with fractions, so I'm going to take the fraction out of the top by multiplying both the top and the bottom by 2. So when I do that, I'm going to get 2 plus the square root of 3 in the top over 4. Because this is a fraction with a radical, we're going to take the radical of the top and the radical of the bottom, or the square root of the bottom, and that's going to be our final answer here. No, it's not pretty. Yes, some indifference would have gave you a prettier looking answer, but they are the same answer ultimately. And again, I'm going to be asking you on the test to specifically use this formula on a certain questions, okay? So please make sure you're understanding how to do or solve for these angles with some indifference as well as half. All right, so this time we're doing tangent of 105. We already know this is in quadrant number 2, okay? And we are going to use the first formula there. So it's going to be tangent of 210 over 2, okay? It's going to equal 1 minus the cosine of 210 over the sine of 210. Okay. Now remember, 210 is indeed in the third quadrant, so both the cosine and the sine are negative. So in the top, we're going to get 1 plus the square root of 3 over 2 over negative 1/2, because sign there is indeed negative. Again, I'm going to get rid of my fractions because I don't enjoy dealing with them. So I'm going to get times 2 in both the top and the bottom. So I'm going to get 2 plus the square root of 3 over negative 1/2 times 2 just gives me a negative 1, which means I need to multiply everything in the top by this negative 1. So I get negative 2 minus the square root of 3. Again, with all those negatives being there, it kind of makes sense because we are supposed to get a negative number in tangent for the second quadrant, okay? All right, cosine of 15. Okay, 15 is in quadrant number 1, so everything is positive. Doubling that angle, we get 30. So cosine of 30 over 15, or sorry, 30 over 2. This is positive because it's in the first quadrant. And so it's going to equal the square root of 1 plus the cosine of 30 over 2. Okay, the cosine of 30 is going to be the square root of 3 over 2. Okay, over 2. Again, multiply top and bottom by 2. So get rid of that fraction. And we're going to get the square root of 2 plus the square root of 3 over 2. Oh, sorry, over 4, because we multiply 2 by 2. And then take the square root of the top. Just leave it looking like its ugly self there. And the square root of the bottom. And there is our final answer. Again, you're going to see an answer similar to this a lot of the time when you're doing sine and cosine. It's just going to be a minus in the top occasionally to make it a little bit different, but you're going to see about the same numbers, just like sum and difference where we get the square root of 6 and the square root of 2 over 4 a lot, okay? It's similar to that. All right, this time we're doing tangent of 15. Okay, again, this is quadrant 1, so we know everything is supposed to be positive. And we're going to get tan of 30 divided by 2. Again, using the first one is a lot easier. You're not going to get that conjugate, so we're going to continue using that one. So we're going to get 1 minus the cosine of 30 over the sine of 30. So that equals 1 minus the square root of 3 over 2 over 1/2. Get rid of the fractions by multiplying by 2. Okay, so we're going to get 2 minus the square root of 3 over 1. So our answer is just 2 minus the square root of 3, which does end up being a positive number because the square root of 3 is 1 point something. So it's still a positive number there. All right, this time we're doing it for pi over 12. Okay, this is also in the first quadrant. You double pi over 12, you're at pi over 6, right? Because pi over 12 times 2 over 1, right, we get a 6 on the bottom, sorry. So we're just getting pi over 6 there. Okay, so we're taking tan of pi over 6 over 2. So that's 1 minus the cosine pi over 6 over the sine of pi over 6. So we're going to get 1 minus the square root of 3 over 2 over 1/2. Again, get rid of the 2's. So we get 2 minus the square root of 3. So notice this was the same as the last one, but it was in terms of radians rather than in terms of degrees. Okay, so this next one is 7 pi over 12. Remember, pi over 2 is the the barrier between quadrant 1 and quadrant 2. So that's 6 pi over 12. So this is actually in quadrant 2, but you know, this is sine, so sine in quadrant 2 is still positive. Okay, so we're going to do sine of 7 pi over 6, because I multiplied that by 2, divided by 2. So we're going to take the square root of 1 minus the cosine of 7 pi over 6, and we're going to divide it by 2. Remember, 7 pi over 6 is in the third quadrant, so it's negative, so that's actually going to become a plus because a negative times a negative is positive, and then it's still the square root of 3 over 2, and then divided by 2. Get rid of that 2 by multiplying the top and the bottom by 2. So we're going to get 2 plus the square root of 3 over 4, and then 2 plus the square root of 3 over 2 as our final answer there. Okay, so now we're going to talk about what happens when we're talking about triangles. Okay, so in right triangles, we are no longer given what u divided by 2 is. We're actually given what u is. So in order to determine which quadrant it is, we have to take its interval for what quadrant it is, and we have to divide everything by 2 because we need u2. Or u divided by 2, sorry. And so when we do that here, we would get pi over 4 and pi over 2, okay, which ends up being in the first quadrant. So if you look down below, I listed out what the quadrants would be originally. So this is quad 1, quad 2, quad 3, quad 4. And if you look below, if you've taken and divided everything by 2, right, we get quadrant 1 for quadrant 1 and quadrant 2. And then we get quadrant 2 for quadrant 3 and for quadrant 4. And for us, the only things that are negative there is cosine. So that's the one that we need to be on the lookout for if we need to put a negative in front. So first off, what quadrant is u divided by 2 going to be in? Right, so we're going to take this whole thing and we're going to divide it by 2, which gives us pi over 4 to pi over 2. So that puts us in quadrant number 1. And then I'm going to draw my triangle. Okay, they told me that the sine was 12 over 13, which means this bottom piece here was 5. Again, Pythagorean theorem, if you don't know that, that is 5. Okay, and then we're just going to find the tangent. So we're going to follow through our tangent formula here. So we're going to do 1 minus the cosine of our triangle over here. So the cosine is x over h, so 5 over 13, divided by the sine, which is 12 over 13. Get rid of those fractions by multiplying the top and the bottom by 13. Which is going to give us 13 minus 5 over 12. Okay, so we're going to get 8 over 12. We're going to simplify that by dividing both by 4. So we get 2 over 3 as our final answer there. One more example of this. They tell us cosine is in quadrant number 1, so that means u over 2 is still going to be in quadrant number 1. So I'm going to draw my triangle. Cosine is 8 over 17, and then over here we would get 15. Again, Pythagorean theorem would show you that it would indeed be 15. We're doing tangent again, so 1 minus the cosine is 8 over 17. And the sine is 15 over 17. Get rid of the fractions. So we get 17 minus 8 over 15, or 9 over 15, which simplifies to 3 over 5. Again, these are half angles. If you have any questions, please feel free to see me in class.